All right. All right, so let's do this warm-up problem here, okay? So, first off, I would put somewhere on my graph, I would put the information that I have, okay? So the first bit of information that I have is that I've got a vertex at 2, 5. So I got a vertex right there, and I have a vertex at 2, -1. So automatically, what does that tell me? Even before that, it opens up and down, right? Okay. Then the next thing it tells me is what, Emma? The center. Where's the center? 2, 2. Yep. Halfway, midpoint of those two. So the center is at 2, 2. Right? Okay. So with it being an up and down one, that's a y minus k type of a parabola, right? And then a minus x minus h. I think I said parabola. I should have said hyperbola there. But it's one of those kinds, correct? Okay. All right. So I've got h and I've got k. What else do I have? What else? I got the b value, right? B value is the distance from the center up. So that's going to be b there, which is 3. Which means that b squared is 9. Right? Okay, got that. Love it. Okay. Anything else that I can get out of where the two vertices are? Not really, right? Okay. So then the next one is the foci. So the foci are located up here and down here. Okay. So this distance here is c, right? And what is c? Square root of 34. Which means that c squared is 34. Right? What's the formula that I got to use with c and b and a? So it's a squared plus b squared equals c squared for this one. So if b squared is 9, and c squared is 34, what's a squared? 25? Okay. Which means a is 5. Do I have enough information now? Oh, yeah. Okay, so it's going to be y minus 2 quantity squared all over 9 minus x minus 2 quantity squared all over 25 equals 1. Yeah, buddy? YB. Yeah, buddy. Okay. Love it. Okay. So today, whoop, tap brakes, hit the wrong button. There we go. So today, we're going to talk about the changing forms of conic sections. Okay? And so we now have 4 different conic sections that we know of. We've got circles, parabolas, ellipses, and hyperbolas. You should have all of these forms already in your notes somewhere, but if not, there they all are. I'll give you a second to rewrite them down, because each form has a little tweak to it. Okay? So in the circle, we've got x minus h quantity squared plus y minus k quantity squared equals r squared. In the parabola, we've either got x minus h quantity squared equals plus or minus 4p times the quantity y minus k, or y minus k quantity squared equals plus or minus 4p times quantity x minus h. In an ellipse, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. In a hyperbola, we've got those two. Okay? Top one, bless you. Top one is for left and right. Bottom one is for ups and downs. Okay? Okay? Now, what we're going to do today is we are going to totally tweak the presentation of the conic. Okay? So far, we've given it to you in the general form. All of the conics so far have been given to you in the general form. Today, starting today, we are not going to do that anymore. We're just going to give you a flat-out straight equation. And you have to decide, 1, what it is, and then 2, getting it into its general form so then you can graph it. Okay? So that's what we're going to do. Okay? Again, these are all in your notes already, so if you don't have them, look back a couple of pages. Okay? All right? So, this is how you differentiate between a conic. Okay? First off, so you've got 4 conics, right? The easiest one to find is the parabola. Why is the parabola the easiest one to find? Only one variable is squared. So if you only see one exponent of 2, that's a parabola. And that's why it's the easiest one to figure out. It's the only one that has one squared variable. All the rest of them have 2 squared variables. X and y are both squared. A hyperbola. If you have the x squared term and the y squared term on the same side, and they're being subtracted, that's a hyperbola. Okay? It's the only one where x squared and y squared are being subtracted. Okay? Circles and ellipses both have 2 squared variables, have addition signs between the 2 squared variables. The difference is, in an ellipse, the coefficients on the squared terms are different. On a circle, the coefficients are the same. Okay? So that's the checklist that you need to run down every time. First, you look and see if it's a parabola. If there's only one squared term, that's a parabola. If there's 2 squared terms, then you look and see if there's a subtraction sign between them. If there is, it's a hyperbola. If there isn't, you look at the coefficients. If they're the same, circle, different, ellipse. Okay? It's a 3-check process. Number of squared terms, subtraction sign, coefficients. Good? All right. So, with that being said, here are 4 different conics that we will be presenting to you. Now, this is the form that they are going to take up. Okay? All right. So, again, it's not general form, but it's pretty close. Okay? So, we need to decipher which conic is which. or which equation, I should say, goes to which conic. Okay? So what I'd like you to do is, if you think you know one, I want you to tell me, and then I want you to justify it.
A is a hyperbola.
Why?
Because the coefficients are different.
The coefficients being different has nothing to do with it. It's the second part that you said. It's just the subtraction part, because it's a hyperbola. Yep. Because of that right there. That's what makes it a hyperbola. Liz?
C is a parabola because
only one variable is squared, so this one, C, is a parabola. I should do this and then that along with that. Makes it up, because there's not a squared term on that one. Okay? Go ahead.
B is an ellipse because they have different coefficients
and they're being added. Yep. On this one, that's a 2, because we've got two squared terms that are being added. That makes it an ellipse. Huh?
So after we figure out what's what, do we have to put them into the
Yep. Huh? Go for it.
D is a circle because if you set the equation wrong, it's the same.
Okay. Or, how many squared terms? There's 2 of them. And what are the coefficients? Both the same, right? Yep, exactly. So, yep, so 2 squared terms being added with 1 there and 1 there. That makes this one be a circle. Love it. Love everything about it. Okay? So that's the first thing you do. Now then, now we got to get into this part. Okay? So I want to graph this conic. I want to put this conic on that graph down there at the bottom that we can barely see, which we'll scroll down because we got to do some work first. Okay? Before I can do that, I got to figure out what kind of conic it is. Okay? I did see her hand first, though. What do you got?
Is it an ellipse?
It's do you agree?
Yes.
Okay. Why?
Because the coefficients are different on the square terms.
And they're being added. Yep, it's got, because that circles and ellipses, we got to give both of those reasonings.
Yeah.
Okay? Hyperbolas and parabolas only need one reason. Circles and ellipses need 2 reasons. There's a double check there. Okay? So we agree that this is an ellipse, right? Okay? So because that this is an ellipse, it needs to be in the form x minus h quantity squared divided by a squared plus y minus k quantity squared divided by b squared equals 1. So we got some work to do, right? Okay? First thing that you need to do is you need to group everything. Okay? All right? So I'm going to change this to be x squared, that's this term, minus 6x, that's that term, right? Then I'm going to leave myself a little gap. Then I'm going to go plus 25y squared, that's that term. Then I'm going to go minus 100y, because I got to get this onto that other side. With me? Okay. Then I'm going to leave a little gap, and I'm going to go equals negative 84. I can leave that negative 84 on the other side. It has to, so it has to be equal to 1, but we also have to factor it out too, right? So we're not quite there yet to having it equal to 1. Okay? Now what I have to do is I have to do a blue completing the square, and I have to do a green completing the square. Okay? Before I can do, or I could do the blue one right away. My b is negative 6. my b over 2 is negative 3, and that squared is 9. Okay? So this gap right here gets filled with plus 9. I'm not there yet. Yep. Okay? So if I add 9 in that gap, where else do I have to add 9? Got to go way over here to this side, and I've got to add 9 to keep it balanced. Okay? On the green one, before I even start, I've got to factor out a 25. Because we only complete the square when the coefficient is equal to 1. So now my b is negative 4. It divided by 2 is negative 2. And it squared is 4. So this gap right here, which now became this gap right there, gets filled with plus 4. But really, what am I adding to that left side? I'm really adding 100 because that plus 4 is inside that parentheses being controlled by the 25. So over here, I've got to add 100. Okay? So now, let me come down to here, and now let me rewrite this, because now the blue factors to be x minus 3 quantity squared, right? The green factors to be plus 25 times y minus 2 quantity squared. And the other side is equal to what? Negative 84 plus 9 plus 100. 25. With me? Questions so far? Ellipses are equal to what? 1. So I've got to still do one more step, and I got to get it equal to 1. So the equation here is going to be x minus 3 quantity squared divided by 25 plus y minus 2 quantity squared divided by 1 equals 1. Cordy, you're giving me a look.
No, I figured it out.
Okay, because we have to divide every term by 25. So 1 divided by 25 looks like that. 25 divided by 25 is 1. 25 divided by 25 is 1. Okay? Now we're in our general form. Okay? So now we can graph that bad boy. What's the center of this ellipse? 3, 2. 1, 2, 3, 1, 2. Center. Boom. There it is. Left and right. How far do I go? 5. Yep. 2, 4, 5. 2, 4, 5. Up and down. How far do I go? 1. Yeah. So it's kind of like a crepe. It's a really thin pancake. Ooh, that's bad. That's bad.
Good job.
That one's hard because it's so thin. It's like a crepe. It's early than pancake.
Ooh. I
Huh?
like that.
Hey, sounds good. So, where are my vertices? We could talk vertices too on this one. Where are my vertices?
-2, 2.
-2, 2, and 8, 2. Where are my foci? Oh, that's a good one. What? Love it, but what don't I like about it? Simplified radical form, right? Okay, so how did we get there? Talk to me. C squared is what? A squared minus B squared, absolute value. So that's going to be 25 minus 1, which is 24. So that's going to be 2 square roots of 6. So then my foci are going to be at, because they're left and right, I'm going to go 3 plus minus 2 square roots of 6, comma, 2.
Question.
What's up?
If we're on a test, we can write it as the 3 plus or minus square root 2. We don't have to write them two separate.
Correct. Correct. But not as 3 plus or minus the square root of 24.
Oh, yeah. But, you just have
But
to
yes, yeah, but yes, that way, yes, just got to simplify it all the way through. Good? Okay. So, this weekend, you will have 3 videos yet to watch. You've got to watch a video on this for a circle, for a parabola, and for a hyperbola. Okay? So you have between now and Tuesday, before your 4-mod class, you got to watch those 3 videos. All told, it's maybe 20 minutes to watch those 3 videos. Yes. Okay? All right? All right? I don't remember the lengths of the videos, but it's for sure it's not longer than a half an hour. Okay? You guys, because you had class today, don't have to watch a 4th video. Those people that don't have class this afternoon have to watch this video too. Okay? Wednesday is your test. Okay? On Wednesday, we will be collecting this blue homework packet. Listen up, listen up. We'll be collecting this blue homework packet, last week's station rotation packet, which is white, and this coming week's station rotation packet. Okay? Right? And don't forget that you get a note card where for sure on your note card, and I'll leave you with this on the video, for sure on your note card, those should be there, and then what everything means in that. You know what I mean? No, steps are okay. Yep, just not an actual example. Remember, no examples on your note card. Just notes.